Okay, so most of what we've looked at up to this point has been working with front end, working in the browser. Not totally, because we did some stuff with Webpack and ES6 that was back end. But now we're going to be focusing on the back end. We're going to talk a little bit about what Node is. So, I mean, we've got a bunch of slides that's here, but I think one of the big takeaways here to sort of think about, and you'll see this in the context of these slides with analogies to cooking. But one way to sort of think about JavaScript is really where it ends up running. Okay? When we end up running JavaScript in the browser, right, the browser is what's processing the JavaScript. There's a JavaScript engine within the browser. So Node is a program where we can write our code in JavaScript, but the difference is that when we end up running it, it ends up running in a Node environment. So when we talk about front end and back end, what we're talking about are really two different environments. And as a result of there being two different environments, there are some things you could do in one environment that you can't really do in another environment. In the Node environment, you don't really have any concept of the back end. There's no API to get to the DOM or that sort of thing. But in the Node Node environment, there's all kinds of things you could do in terms of making calls to databases, opening up files and reading them, bringing in other libraries. Some things, the code might look similar on the front end and the back end, especially if we end up using something like Webpack, where it might end up looking exactly the same on the front end and the back end. But the language is the same. The environments are different, or what you could say is what you can do in those environments is very different. So we're going to look a little bit about some hardware stuff, which I have to tell you I'm no expert on. I'll tell you what I'm very good at, and this is, again, I'm going to be relying on the slides quite a bit. We'll look at a little bit of history. We'll talk about Node as a process. We'll talk about Node modules, and really the big focus for us is going to be sort of looking at the last three things that are on this slide. So one thing that we could sort of talk about is multitasking, how things work, and if we end up looking at it within the context of a kitchen, right? There could be a lot of things that are happening within the kitchen. If we sort of break things down in terms of a program and a process, right? We can sort of think about our program as the files that we have that don't end up doing anything, but the process is sort of when they end up getting executed, right? So you could sort of the process, the program is going to be loaded within a process. It has to end up running somewhere. It has to end up running in some environment, whether that environment is on the client or whether it's on the server. So we sort of look at this analogy here. We could think of the program as some recipe, and the act of cooking as the process that's utilizing the recipe, right? The process is utilizing the program or is loading the program. So where does all this happen, right? This is happening, the processes are running within the CPU, and this would be the analogy to the chef. And the fact is that the CPUs themselves are totally unaware of different languages that we end up writing in, and in some way the programs that we write, which could be JavaScript, C#, Java, pick a language, at some point are going to be processed down to machine code so they could end up running on the CPU. So we've got the chef that's in the kitchen that's doing all these things, right? Things can get a little bit hectic, right? When we talk about the engine itself that's doing this, what we're really talking about is, in Node at least, is this V8 engine. And not just in Node, but this V8 engine is actually the engine that's used in Chrome as well. So when you end up, running a JavaScript on the browser, it's also using the V8 engine, but the fact is the tools that it has on the browser are very different than the tools that it has when it's operating on the server. So how do you actually go about it? Again, this is just some hardware stuff. If you have this CPU, how do you have all these different programs that are running? And really, what it ends up coming down to is that you have this CPU, which is very expensive, very limited. And what happens is that the reason why you could end up running multiple programs is that underneath the covers, this is not obvious to you, but there's time slicing that's happening where different programs are getting access to the CPU for a certain period of time, and it's the operating system that's controlling this. So you have this whole idea of these different processes that are running right on this CPU, right, and the operating system is controlling who gets access to it. So, one of the things you can do, I mean, if you open up your activity monitor, you could see that there's a ton of things that are going to be running. I don't know if you guys ever run into it, but sometimes I run into this. One of the interesting things is just that the browser has become such a center for applications that you run. So very often in Chrome, you go and there is so much memory that Chrome is eating that you have to basically restart Chrome. And sometimes you can't even do it anywhere other than going to the activity monitor and just shutting it down. So, I mean, you go to the activity monitor, you'd see what's running, you'd see, which processes are taking up the most memory and that sort of thing. So then you have this other concept of what if the process itself needs to do multiple things, right? So you have different processes that are vying for the attention of the CPU. You have the operating system that's controlling that, but very often you might want to have multiple things that are happening in a process, and this is really where threads end up coming in. So you can have a thread, which is going to be a sequence of steps, and you could have multiple threads per process. And you see that if you end up opening up, your activity monitor, right, you could actually see the number of threads that are running for a particular process. So one thing that you sort of run into is that when you look at this, the big sort of takeaway here is just that the processes themselves have access to some allocated memory that your operating system is taking care of. And again, this is not something that you probably have to worry about unless you were writing operating system code. But you could have these multiple threads that are running within these processes. Look, if we end up going out a little bit, we could sort of look at the fact that you could end up having, multiple processors as well. That, again, might give you some more ability to do multitasking. You also have some ability to have, multiple cores within a processor. And again, if we sort of take the analogy of the kitchen, you could have, several chefs working at the same time. There's also this idea of hyperthreading, which honestly I don't really know all that much about, but I guess the analogy here is that maybe the chef has some helpers, or you could sort of think about, that as the chef, doing something with his, his two hands. So the big sort of takeaway here is that when we think about a program, we can think about a file. It ends up getting loaded into a process. A process has multiple threads, right? The threads are the sequence of operations. The operating system is controlling this, and the work itself is being done by the CPU. So we could also take a look at, we do just a sort of very quick demo of looking at Node. Just take a little detour here. So if I end up creating this directory and CD into it, right, so one of the things I could do here is that if I end up creating a file, and I go in here and I'll call this index.js, nothing is going to prevent me from going in here and saying console.log hello, right? Now, again, we're used to opening up those files within the context of a browser, but there's nothing that says that I can't go in here and go over here. And actually, if I hit the tab, index.js will end up showing up. And I could end up putting in hello. Now, it's interesting. You could look at this and say, well, where's Webpack going to come in this thing? And we don't really need Webpack because Node allows us to load things through a module system, right? And you've seen this sort of thing. We've done it. We've been able to do it with Webpack. But for instance, we could go over here, and I could decide to get rid of this. And so Node has this module system. And if I go over here and I say, you might as well use some ES6 syntax here because Node understands it. And I go over here and I say constant foo equals require foo, right? What this is saying is that we have some file here that's going to be a module, and I could end up doing that. And if I went to go and run this index.js, I would get this error message because it can't find this file. But if I was to go in here and create foo.js, now if I went to run this again, it'll run, but nothing really is going to happen. Now, how do you end up getting things out of your module? Well, let's use this sort of standard module exports syntax. And so if you want to get something out of a module, you could say module exports. And we could go in here, and I could create a function, say hi. And we could use ES6. And let's make sure we don't have any errors there. That loads, and let's go here. And we've got our foo, and we'll say foo, say hi. And say hi, right? So the way that we end up, again, a big advantage of this setup is that we have the ability right off the bat to organize things in a way that kind of makes sense. So when you're running in an environment of the browser, it's a bit different because in the environment of the browser, basically everything ends up loading. Okay? It's basically a request and a response, and your web page ends up loading. Here, we have the module system built in, and we can end up requiring things when we need them. And this allows us to, encapsulate our code in a much nicer way. So to sort of beat a dead horse here, right? To go over here and, export something else. And if we went here, we could do this, right? By the way, nothing prevents us from going in here and creating a class called bar, putting a constructor in here, using some ES6 and saying to our constructor, we're going to pass in a name, this dot name equals name. Nothing prevents us from outputting this as well or making this available by saying, bar is equal to bar. And I guess if we are using our ES6, we could probably just get away with doing that, right? So now, if we ended up going back here, bar equals new foo bar prof. That's the name. And let's do console.log just to see it, bar. Right? So it basically is giving me a representation of that object. Now, that's fine. There's nothing that's different that you couldn't do with Webpack that does the same thing. But there's also a bunch of different modules that are part of the Node ecosystem that are already there. Now, we could install other modules as well. It's fairly limited in terms of what's part of the Node ecosystem, but Node has the ability to do some interesting I/O work. So one of the things that Node could do, this is always kind of cool. What we're going to do here is, let's get rid of this. And I'm going to bring in a const, and this is going to be fs. Now notice the difference here. This is a module that is part of the Node ecosystem. Okay? If in fact it couldn't find that, you saw that I got an error before, right? If I do this, okay, I don't get any sort of error. If I did that, I'll get an error that it can't find the FSA module. Okay? So Node has some, when you end up installing Node, there's some modules that are there. In fact, one of the things you could do, as an aside, you could actually open up Node right here. And you could go over here and actually put in some Node commands. I could say console.log, hello. All right, this is basically going to allow me to test out some Node commands. In fact, I could probably go over here and say foo equals require foo. I'll get foo, and I could say foo, say hi, and it'll end up saying hello. Okay? So you could actually open up the Node environment here to sort of test some of these things out, and you could get out of it, Control-C again will end up getting you out of it. Remember we ended up working with that Faker API? Okay? So let's say I went into the Node environment, and I said Faker, actually probably don't have to put a var here, just interacting with this, and I say require Faker. Okay? Tells me it can't find Faker. Let me get out of this. And I'm going to do an npm init, and I'll save it. And if I wanted to have Faker in my project, npm install Faker, and I'll save it. Now when I go in here, I'll say Faker equals require Faker. It'll tell me all the things that I could do with Faker. So if I say Faker, look at your commerce object, and there's a function called color. Give me a color. Have a color. Random colors. Okay? Faker, give me a email address. Faker, internet object, email. And it'll just generate some fake data for you. Okay? So again, there are modules that are part of the system. If I could go in here and say fs equals require fs. Now I've got this fs object, and this is a built-in object that's going to allow me to interact with the file system. There's an HTTP object that will allow me to create a server. So there's a bunch of built-in objects that you have where when you see these other libraries that do a lot of fancy things, they're just basically sitting on all of the other libraries that are part of the Node ecosystem. And very often Faker, or one of these other libraries, is going to be relying upon another library, right? So you'll end up getting those as well. So as an example of sort of reading a file, let's go over here and say we're going to get our file. And one of the things we could do is we could say fs read file. And the file that I'm going to read, this might seem a little bit weird, but the file that I'm going to read is going to be index.js. Let's just see what happens. So I'm going to say node okay, no errors, okay? But I'll go over here, and I want to actually get this data that I'm reading. Now, one of the things with Node that we're going to find out is that Node handles expensive operations in a very interesting way. Node doesn't block, okay? So what ends up happening when Node runs, if there's anything that's going to be an expensive operation, okay, whoever ends up writing that code that's going to have any sort of input-output, what they'll end up doing is that internally they'll have it run on another thread, okay? it'll basically end up running on another thread. Even though we don't really have access to those threads, what we can do is we could specify a function. All right, and let's look at what that function looks like. We'll say console.log arguments. Let's run this file. Interesting, right? We end up getting back two parameters. What do you think that first parameter might be? Correct, right? Very, very common syntax for these callbacks is to specify, hey, look, something is going to happen that's slow, okay? I don't want my program being blocked, okay? What does that feel like when we had that callback function? What did that feel like in something we looked at earlier? Click event, right? There, we're not really necessary about worrying about blocking, but it's the same sort of thing. It's something that's asynchronous, okay? Again, we hope that this function ends up getting called, which it is, and you can probably see that this is some buffer that we get back, which is a series of characters. Now, if we want to look at this a little bit more, we could give another parameter to this and specify that we know the encoding for this data that's in that file, and then we'll actually get a string, okay? So, one thing that's pretty common is to go over here and specify data, and here you might want to do some sniffing. In fact, if you have an error, thank you. So here, this is going to be the error. This is a pretty common method. So if there's an error, let's console log the error. We don't expect there to be an error. If there's an error, we never made it to this program. Otherwise, console.log the data. Okay? It's up to us to do some sniffing to look when this function gets called to see whether we have it or not. By the way, this could have been written differently. It could have been written in a way that we pass in two callback functions. And the first callback function is for success, and the second one is for failure. But this is just the sort of standard way that a lot of libraries have been written. If you want to know what structure your callback function is, you look at the API. So there's an API for the file system that tells you how things are going to be read. So if we do this, we'll end up getting back pretty much those same results, but here we've got a more formatted version of that file. I just want to do one other thing, and then we'll sort of bounce back. But notice what's going to get called first? Hello or looking at the data? It's going to get called. Well, what's going to get called first? The console.log here or the console.log here? Hello, right? Because this is asynchronous, okay? What's actually happening here, and we'll see a slide for this, but there's basically something in Node called an event loop. And what happens is that you specify, hey, look, when this is done, I want you to call this function. And what happens is when it's done, okay, the function won't get called, but it'll go on the event loop that specifies, hey, look, the next time that I'm free, okay, I will end up basically running this callback function. Again, the main thread can only do one thing at a time. So in other words, if we had something that was delaying, down here, okay, it would take us a while to end up seeing these results. Let me do one more example of this. What if we do, so one of the things that we could do, you've seen this already. Well, you've seen set interval.
You need another bracket after helmet.
Yeah, let me put that in. Thank you. So we do console.log, right? We've got this. We're using our ES6. Unexpected token. I think maybe Oh, thank you. So one of the things that happens is notice that my program didn't execute. Same way when I ended up reading a file. Node says, hey, look, there's something going on here. I'm not going to execute the program yet. Okay? And it waits. Well, what if we do this? Set timeout, 0 seconds. And I put a console.log here. I'm going to do hello here. And I'm going to do done here. What do you expect to happen first? Hello is going to happen first. Even though we say 0 seconds, okay, what will happen is that it'll be put on the event loop. It'll get called immediately, but we've already progressed down here, and this will end up running first. Same way, by the way, if we ended up doing right, this is another example of it, right? Let's take this out. I plus plus. I can't, obviously, right, this has to be a let. Yeah, it's an example of using a let. Okay? Notice that, and it wouldn't matter, by the way, if it took, let's assume it took a long time to get those numbers back. Okay? Again, that has to finish, okay, before something else happens. I mean, really, look, the bottom line is that when you work with Node, you're working with, Node has one thread, so very often you're dealing with callbacks. Not all programming languages have that. A lot of programming languages don't have the idea of callbacks, and when they want to do something where something is going to be slow, they'll just end up adding more processes to it. So let's go back to our lecture here.
Wait, just a question.
Yeah.
So, real quick, set timeout starts a thread, and that goes asynchronously from the thread running the rest of it, which is declaring that constant and then running the while. First of all, is that right?
Well, what I would say is that we're basically setting up another thread, okay, and we're putting in this callback, okay, that gets called in 0 milliseconds, right? So this other thread basically says, all right, I'm actually done almost immediately. And it goes to Node and it says, all right, I'm ready for this thing to be run. And it puts it on what's called the event loop. And when the main thread is free, it will end up calling that function. Okay. But if the main thread is sitting there and going through this while loop, it ain't free.
So all threads are not equal. There's a primary.
There is and the only thread that we really have access to is the main one. Okay? Although there are ways of actually creating other threads in Node. It's not something I've ever done, and I work with Node all the time. But there are ways to do it, obviously, because someone who ended up writing this library, right, ended up creating threads that end up, opening up these other files. So
can I ask a secondary question?
Sure.
So if you did another set timeout before that timeout and set it to 2 minutes.
Well, that's a good question. So let's say we did one before this, and we set it to 1.
It wouldn't really matter though,
So
right?
that would be so they would actually you'd feel like it would be running backwards. The while would go first.
Well, yeah, because it's not that it's running backwards. That we specified that it's going to end up getting called. So this should be the last thing that ends up getting called.
That's really what I was getting at.
Right? That's not even true. Done last is happening first.
Yeah, because does it set timeout not guarantee order?
It's probably correct.
If you put 10, probably.
Yeah.
Because it
Went on the event loop.
The thread loop, the thread queue first.
Yeah, and this is not something that, again, I don't think you could operate under, I think in essence, very often you just have to make sure that if you're expecting some data and you need that data before you do something else, you better get that data first, okay? you can't say, oh, let me just wait a couple of seconds and my file will end up getting read or whatever. Let me wait 100 milliseconds and it should be done. You don't know. Okay? That's why you end up having to call back. And I would just say this, is that once we end up getting deeper into Node and we end up working with something called promises, we'll find out that callbacks are good until you've got a callback within a callback, within a callback, within another callback, and there could be an error at some point within the callback, and that's where promises ended up getting created, which is basically an abstraction over all of these callbacks, and you don't need to know it now, but as you go in, and even in today's workshop, you'll see that there's somewhat of a need for these things. So let's just continue with this. So you've seen Node as a process, just sort of looking a little bit about, at time frames here, right? We've got Node that's running with the V8 engine. We've got Chrome that's running with the V8 engine. And you know these things in Chrome because you've used the window object, you used the document object, maybe not history. When we look at Node, there's other objects that we have access to. And in the end, when we think about these things, we think about the environment. We can sort of think about these as being the kitchen, and we've got, different tools. So, in the end, what's going to happen is that this V8 engine is going to end up doing the work of translating this JavaScript code that we end up writing to something closer to machine code that could end up running within some process. Now, one thing to sort of be aware of is that we've got this idea of things that are synchronous and things that aren't. You've seen this. Like, we end up doing a while loop that's synchronous, right? But we also have the idea of things that are asynchronous, and we've seen these, we've actually used these. We know for sure the simplest one is the on-click event, because obviously it doesn't happen immediately, right? It happens at some point in the future. But we've also seen it with the set timeout as well. And again, this is where we have this whole concept of the event loop happening. You should be aware of what it is, but it's not like you have to access it directly. So if we end up looking at this, if we have sort of a, asynchronous stuff also, one of the things that we'll end up looking into is that we'll end up looking at, setting up a server with Node. And again, that's going to be asynchronous too. And there's a couple of different pieces to that, but we'll see that there's going to be this process that's running. The Node process is going to be running. It's going to be listening for requests coming in. We're going to handle those requests, and we'll end up sending responses. On the same token, we might interact with a database. Okay, that's also, it better be asynchronous. Anything with I/O better be asynchronous, because if it's not, you're going to be totally blocking that main thread. Okay, so we could look a little bit about some sort of metaphors with this thing, right? We've seen this before, right? We've got our environment, which is the kitchen. We've got our program, which is the recipe. We've got the language, which is JavaScript. So this is sort of the analogy here. A big use case that we could sort of think about is that we've got an HTTP object that we can end up creating, where we could end up creating a server that's going to be listening for responses, and we could end up handling those responses. And I think what we're sort of looking at here is that, we could sort of make a distinction as to, what we would sort of consider blocking and what we could consider, non-blocking. But again, if we could end up doing something pretty fast, right, in memory, then we would say that we don't necessarily need that to be blocking. But if we're doing anything that's going to involve I/O, right, that's something that we want to be aware of. So, how do actually different, machines end up handling that? So if something was blocking, we would be pretty much, dead in the water. As opposed to where something is non-blocking, where we have this other sort of process that's running, that's handling it, we end up handling it with callbacks. And then there's other sort of environments, and there's other languages where what'll happen is that if you had multiple requests, you could basically just, spin up another process. So even if something is blocked in one process, you have another thread that's going for the other process. In the end, I mean, you really want to avoid this anything blocking, because that's obviously going to throw you off. So one of the things that happens if you've ever sort of worked with threads, they're really a drag to work with. What's nice is that with JavaScript, you don't have to worry about that. And just a little bit of an analogy, right? There's different servers, so that, for an Apache server, when requests come in, there's another thread that ends up getting, put on for requests that end up coming in, where Nginx ends up using more of an event loop, which, again, makes it a lot faster. So this is a quote from the guy that ended up, figuring out, coming up with Node. And again, if we think about Node, right, we could basically say it's single-threaded, right? It's event-driven. We don't want to block that thread. That's not really exactly the case, but for all intents and purposes, we could think about it as being single-threaded and say, arguably, that's correct, right? So we have Node that's sitting on top of these. We have JavaScript, and we've got the V8 engine. Again, the V8 engine is going to end up doing the work for us of basically turning our JavaScript into machine code. And one of the things that we could sort of see here, and we actually saw it with an example, is that we have this call stack, and we've got these other threads that are working, and we've got this task queue on our event loop. And really what ends up happening is that when the main thread ends up getting a break and you have a callback, right, that callback will end up getting called. And again, the best way to see that was with the example where we did a set timeout of 0, but we had that while loop that was running, and that while loop ended up printing out all those numbers, because in that case, our call stack wasn't empty, couldn't end up running. But once our call stack is empty, if we have a callback that should be run, it ends up getting run. So let me stop this.